Good afternoon, everybody. We're here at the Winkel van Sinkel as part of our Vlog Community Day. Vlog Community Days, as you've known and you've seen, it's all about giving you people a workspace, place to work, some good internet, some good coffee, some quirky discussions you can have either amongst colleagues or other engineers. It's about bringing you inspiration, which we're going to have with this talk from Bouke and Nijhuis. And it's also a little bit about cross-pollination. For lack of a better word, it's about connecting with other people and having those internal discussions or external discussions about problems that either are bugging you personally, professionally. And we're here to listen to a talk right now for about 40 minutes, after which we can have some drinks. But before that, of course, we have to pay attention to Bouke and Nijhuis, who's going to tell us everything about TDD and generative AI, whether or not it's a perfect pairing. So give a warm welcome to Bouke and Nijhuis.
Did you just say I have 40 minutes? 40. Okay, if everything goes perfect, if everything goes well, it will be 40 minutes. If I have live demos fail, I need a little bit more time, but hopefully everything will go smooth. So welcome everybody, thank you for attending this talk. Let's start with the why. Why am I here on stage? Why am I talking about TDD and Gen AI? That is because last year I had another talk called The Battle of the AI Coding Assistants. I gave this talk at multiple conferences and meetups, and in this talk I showed off features of AI coding assistants. Think about JetBrains, AI Assistant, GitHub Copilot, JetGPT, and it worked pretty well. One of the features that I showed off was generating tests. So how does that work? You give the AI your implementation, you ask for tests, and it comes up with tests. This is a feature that works pretty well. It comes up with happy flows, and also it comes up with edge cases. After one of those conferences, a discussion started, and somebody asked, can we also do it the other way around? And I said, that's a very good question. I don't know the answer, but I'm going to dive into it and I'm going to get back to you. So I started diving into this question, and that led to this talk. The second thing I would like to do is title this section, because there are 3 IT concepts in the title. 2 of them are pretty obvious. The first one is test-driven development, TDD. The second one, also pretty obvious, generative, let's say Gen AI, because I have difficulties pronouncing generative. But the third one is hidden in plain sight. So the third one is pair programming, and it's hidden in the subtitle, the perfect pair. So we're going to see if those 3 IT concepts, if we can combine them into something new. But before I'm going to do that, we're going to shortly talk about all those 3 concepts. So let's start with Gen AI. JetGPT is the most famous one. It is introduced to the world 18 months ago, so only 1.5 years ago. For me, it feels so much longer. I'm not sure about you, but for me, it feels like it has been with us for years. And for a long time, it was the only big AI assistant out there, but 18 months later, every big company nowadays has their own AI assistant, or they bought an AI assistant. And something that all those AI assistants have in common is the fact that they run on something called a large language model, an LLM. And those are pretty good at generating text and code. And code is the thing that we're going to talk about today. We're going to use LLMs to generate code. So the next concept is test-driven development. This is something you can hold entire conferences about, but for this talk, I'm just going to boil it down to write tests in advance. This is better than doing it afterwards. There's also several reasons to do this, why you should write tests first. But for me, the best reason is the fact that I really believe in the following. The more you think about something, the better the result will be. So if you start with writing tests, you think a lot about your implementation, and therefore you will have a better implementation. It also goes really well with pair programming. So let's talk about pair programming. So pair programming is really simple. You write software in pairs. So you sit together behind one computer and you solve a problem. You write software together. Normally you do that in 2 roles. We have the driver, that's the one sitting behind the keyboard, typing away, solving the issues. And you have the other one called the observer or navigator, and that's the person you're discussing with, and that's a person that's giving live feedback to your code. Also, a thing that happens a lot where you're doing pair programming is that one person writes the test, you switch chairs, and the other person writes the implementation. So Those are the 3 IT concepts. We're all on the same page now. Let's see if we can combine them into something new. Let's see if we can create a perfect tripling. So the idea is as follows. We're going to pair program with the Gen AI. The human will write the tests, and the AI will try to write the implementation. And I call this test-driven generation. So not test-driven development, but test-driven generation. Now, a point I would like to make, I would like to stress, is the fact that tests have a double purpose in this idea. I already talked about the first purpose of tests. It's the input. You give the test to the AI and you ask for an implementation. The AI needs some context to come up with a proper implementation. But far more important is the second purpose of tests in this idea. We're going to use the test to check for correctness. You've all been working with large language models in the last few months. And you all also know that large language models tend to make things up. Sometimes they just say things that are not true. And that's a problem, especially when you want to write production code. We don't want production code with made things up in there. We don't want production code with errors in there. We want correct production code. We want working production code. Let me give you a little example of an AI that made things up. So this was in the news a few months ago. It's about Air Canada. Air Canada is an airliner. They have a website, like most airliners do. But their website also had a chatbot. And they decided to improve their chatbot by adding a large language model to the chatbot, so they would get more natural responses, which in the basis is a good idea. So they did, and the customer was chatting with his chatbot, and they were talking about refund policies. Now, everybody can imagine what happened. The chatbot started to make things up, his own refund policies. The customer had some foresight, so he made screenshots. We waited a few weeks, nothing happened, and then the customer decided to ask for a refund. So he called the help desk with actual humans behind it, and he said, hey, I would like to refund my ticket. And the human said, no, that's not possible. This is not a real refund policy. Our chatbot made a mistake. The customer said, too bad, I'm going to go to court. So the customer went to court, and the judge agreed with the customer. The judge said, I don't care if it's a human or a chatbot or large language model that puts stuff on your website. If it's on your website, it is true. Therefore, you have to refund the customer. Next day, the chatbot was offline. So I really think this example illustrates why we should check the output of large language models. Lucky for us, we're going to talk about code, and we have a way to check the correctness of code. We use unit tests to check the correctness of code. Okay, my name is Bouke Nijhuis. I'm the CTO at a company called ThinkICT, and we're going to talk about the intersection of test-driven development and Gen AI, and we're going to see together if it is a perfect pairing. So I created a little schema in Excalidraw, my favorite drawing tool, and this is how we're going to do it. So I'm going to take you from the left to the right, so it's straight arrow, the happy path, and then I'm going to talk about the loops in there. We start on the left, we have the tests, I talked about that. This is the input for the Gen AI, so we ask the Gen AI, give me an implementation that passes this test. This is the happy flow, so I get a perfect implementation. That's the box in the middle. And then we run tests against this implementation. It's a perfect implementation, happy flow. Therefore, all tests pass, and we follow the yes arrow, and we're done. We have production code. Let's ship it. This is the happy flow. This is the idea, but of course, in practice, things go wrong. Therefore, we have loops. Let's start with a small loop under Gen AI. I call this the code loop. So sometimes Gen AI comes up with an explanation instead of an implementation. You cannot run tests against an explanation. Sometimes Gen AI comes up with a non-compiling code. Again, you cannot run tests against non-compiling code. Let's go to the big loop on top. So sometimes not all tests pass. If this is the case, we extract the errors from the test, we feed them back to the Gen AI, and we ask for a new implementation, one that will solve, that will pass the test that didn't pass before. And this is the idea in a nutshell. Now, the best way to show off an idea is, of course, wrong button, with a demo. And we're going to start really simple. Before I'm going to start, most people are capable of reading Java, I assume. Are there people? Now, if you're not, don't worry. I'm not going to go in depth. I'm just going to keep it high level, and I will explain what I'm doing. And now, more about that later. I'm going to start really simple. I'm going to start with something called an odd-even test. Let me show you what it is. So we have a test here, and for people who do not know Java, this is how you write a unit test in JUnit 5. For Java, it doesn't really matter, but it is a test. That's the most important thing. It expects there to be an object called odd-even. This odd-even object has one method called isEven. If you provide it an even number, we expect the method to return true. And if you give it an odd number, we expect it to return false. As I said before, no rocket science, really simple, just to show off the process. So I'm going to select the code. I'm going to go to the grandfather of AIs, ChatGPT, and I'm going to ask it, please, bless you, by the way, to implement a class that passes. You people aren't friendly to your AIs? You should be. You never know what's going to happen in the future. So I typed the prompt, and I'm going to paste the code. And now we wait till it comes up with an explanation. Now, for people who do know Java and programming, this is the proper solution, but hey, that's expected because this is really, really simple. I'm going to copy the code. I'm going to go here. I'm going to go to the test subject. Notice that I have a dummy implementation here, which is incorrect. Then I'm going to replace the code by the code from ChatGPT. I'm going to go back to the test, and I'm going to run the test, and we're going to hope that the test will be green. Woohoo! Green test. So this was really simple. So let's step it up a little bit, and we're going to do prime number generation. So I have another test called prime number generator test, this one. And it's again pretty simple. It's a test. It's called under 50. It expects an object to be there called prime number generator. It has one method called generate. This method takes an integer as input. This integer denotes the upper bound of prime numbers to generate. So if you feed it 50, we expect it to return those prime numbers, right? So we're going to copy it again. We're going to go to ChatGPT. We ask it again. Can we do? No, it doesn't work. Too bad. Please provide an implementation that passes this test. And I paste the code. Now again, we're going to wait for the code. The code will be much more than before. We're not going to focus on the code. We don't need to focus on the code because we have unit tests to check if the code is correct. So I'm going to copy it. I'm going to go here, back to the test subject. Again, dummy implementation, that's incorrect. I'm going to replace it by the code from ChatGPT. Back to the test. Let's run the test. And again, a green check mark. Woohoo! The principle works. I see a question.
Yeah, did it actually try to implement your test, or did it recognize the prime number stuff and got some prime number?
Very good question. The first version of this talk had something about that, but it became too long. I had to drill it down to 40 minutes. Thanks for that. No, just kidding. So I tried it also by anonymizing all the variable names, all the method names. If you do that, it still works. It was pretty impressive. Yeah, I was also wondering, will it work if there are no English words in there? It will work. It does understand, maybe not the correct verb, but it does understand algorithms. So, the principle works. End of talk. Thank you. No, I'm just kidding. I'm pretty happy with the fact. Sorry, what?
Does it take the upper bound into limits?
You wanna check the code?
Yeah, I was just wondering.
Yeah, I'm not going to do it on purpose because the entire idea behind this talk is we don't focus on implementation anymore. We only focus on writing the right tests. So then, if you want to check that, you should write more edge case tests. So then the tool, the principle solves it for you. Where was I? Oh yeah. I'm really happy that the fact that the principle works, but there are two big issues. And the first big issue is the next one. Too many manual steps. So let me take you a little bit back. So I was in my IDE, I copied code, I went to my browser, I typed in a prompt, I pasted code, pressed enter, wait for the answer, extracted the code, went back to my IDE, went to the test subject, pasted the code, run the test, Talking about this makes me tired. Imagine doing this. So, too many manual steps. So what do you do if you have too many manual steps and you're a programmer? You automate it. Yeah, let's automate this. So that's what I did. Sounds simple, right? You just saw me doing the demo, so have a bit of code, a bit of prompting, do some stuff. How hard can it be? That's what I thought. So in my head, I had this planning of 3 to 5 evenings to create something that automates this. Harder than expected, like a real project. So in the end, I spent 10 to 15 evenings and a few weekends. Okay, and I learned something. I learned that the IDE does a lot of work for you. Of course, I already knew that the IDE does a lot of work for me, otherwise I wouldn't use it, right? But it never became more apparent than in creating this tool, and I will come back to this later. So in the end, I had a tool called the test-driven generator, and before I'm going to demo it to you, which will be, of course, in this presentation, I'm first going to take you through all the steps that it does. So probably you recognize this as part of the schema I've showed you before. This is the beginning part on the left. And the first thing the tool has to do, it has to call the API of a GenAI. I started out by using JetGPT because that's the one that I was most familiar with. It's not difficult, but it's work. Then you have to interpret the reply. So the large language model comes up with output, and as you could have seen in the browser, in most cases there is some explanation, then there's some code, and then there's some explanation again. So you have to extract the code from the entire answer. Again, not really difficult, but also not really easy because it is not always in the same format. So in the browser it looks always the same, but it's not true when you use the API. It's always a bit difficult, and it becomes more difficult if you use other large language models, because they're not all the same. Then we have to create a file. We have to put the code somewhere, right? And if you know Java, you know that the file name of the file should be equal to the public class name of the class. So we need a feature to extract the public class name and transform it into a file name. Then, if there are packages involved, you have to put the file in the right position. So I need a feature to extract the packages, and then I need to create the corresponding file structure on the file system. The next thing we have to do, we have to compile both files. So you have to compile the implementation file and the test file. I didn't think about that. I never think about compiling files. This is something that the IDE does for you, right? Who manually compiled files in the last year? Raise of hands. 2 people, 3 people, okay. You don't use IDEs? Fine with me. You don't do Java, very good. Same for this. You have to load both classes into the JVM. I didn't think about that. It's also, again, something that the IDE does for you. You don't have to think about it. It just happens in the background. It's became ubiquitous. Is that the word? I don't know. So you don't have to think about it. You have to add the test library. Normally, I put a JUnit dependency in my POM, and then IntelliJ takes care of the rest. I had to do some stuff to add the test library. Then you have to run the tests from code. And normally, in my IDE, I just press the green triangle and I wait. But now I had to run tests from code. Never done that before. It's not hard, but again, work. Then you have to interpret the results. Again, in IntelliJ, I just have a nice table. I have check marks if it works, or yellow crosses if it doesn't work. Now I have to grab all those information from memory structures, from data structures from memory. And once all tests pass, I copy the implementation from the temp directory where I do all my compilations and all my stuff back to the project where the test file came from, so you can directly use it. Then we have the big loop on top. If not all tests pass, we have to extract the errors. Simple thing to do in your IDE because you get a nice table. A little bit harder to do in code, but not really difficult. Then, interesting thing, what we want to do, we want to continue the conversation with GenAI. So I gave it its first, I asked for an implementation, not all tests passed, so I extracted the errors, fed them back to GenAI, and I asked for a new implementation. If you do this in JetGPT in a browser, there is a context mechanism. It knows what you talked about before. This is not the case when you use the API. So you have to build the context mechanism yourself. And lastly, I needed proper logging. Why? Now, like every hobby pet project out there, you start with a few system out print lines and it works fine until you get a lot of logging. Now, if you get a few loops in the schema I've shown you before, we got a lot of, you send the Java, all the test lines, you send them to the AI, it comes up with an answer. The answer contains implementation, but also explanations. Then you prompt it again and again and again, and you get a lot of lines of code and a lot of lines of logging. So I needed proper logging. I also told you that I started out with JetGPT, but halfway the project I decided let's try out local large language models, because those are getting better and better, and you hear more and more about them. And I was surprised. They are easier and faster than I expected. I expected them to be really hard. I expected to download a big file, do 20 manual steps, and then fingers crossed, let's hope that it works on my machine. Turns out you just download one tool, Ollama, you run a model, and off you go. Also, I expected the answers to take minutes, and it turns out that it only takes like 10 to 20 seconds for an answer, at least on this machine. This is a M1 machine. It's even better when you have an M3. There are lots of local coding large language models out there. Notice that I specifically say coding LLM. There are even more general purpose LLMs out there. I tried about 10 of those local coding LLMs, and in the end I settled on something called Llama 3. It came out, I think, about 4 to 6 weeks ago, and it just works best for this use case. So for the next demos, I will use Llama 3 as default local large language model. Hey, demo time. Favorite time. This is for me. I always forget to do this. If I don't do this, I cheat. Oh, we should not do this. I'm going to do a git reset hard. So now I've removed the implementations that JetGPT gave in the previous demo. And to prove that I'm not lying to you, look at that. We have return 0. So the tool in its current form is just a jar file, like this. What it needs is a path to a JUnit 5 test file. So I'm going to give that to the tool. So what we're going to do, again, we're going to do prime number generated test, but now with all the manual steps. So I'm copy the path to this file. I paste it down here, and I'm going to press enter. So what's happening? You see some logging. We're in the first test loop. The test loop is the big loop on top, and within the first test loop, we're in the first code loop, which was a small loop underneath the Gen AI. And currently, we're asking my local Llama 3 model to come up with an implementation for the test that you see on top. Hey, and look at that. It came up with an implementation. It found one test, this test, and it ran the test against the proposed implementation, and it succeeded. So let's see what it created. Last line, it copies the solution back to the project. So I can over here just go back to the test subject, and look at that. We're not going to dive into the code, but we have a working solution. How do I know that? Because the test succeeded. So the tool works as well, and I'm really happy with that, because now I can just write a unit test, feed it to the tool, grab a cup of coffee, come back, and hopefully I have a working solution. It saves me a lot of manual work. I've just shown you how you do it manually. That takes too much steps, but now we have a tool that takes all the work out of our hands. And now we have the tool, we can talk about some other stuff, like how would you add features in this concept? Normally, when you don't use the tool, you would write more algorithms, right? You would go to the implementation and add features and add features and add features, and also tests, of course. But we're not allowed, not allowed. The idea is that we do not touch the implementation, because that's the area of the AI. We write the test, right? And that's also the answer to the question. If you want features, you just write more tests. And that's what we're going to do. So let me show you. Let's go back to the test. So we have a test under 50, and I told you if you provide an integer, this will be the upper bound of the prime numbers that will be generated. So if you provided a negative number, you're actually asking for negative prime numbers, and as far as I know, they do not exist. Therefore, I want the implementation to throw an exception whenever you ask for negative prime numbers. So how do you do that? We're going to add a test. So you just write a new test. You see this? This is not correct, but I really like it. This is the one-line code completion thingy from JetBrains. I have an under 50, so it thinks probably you also need an over 50. It's incorrect, but still, I think it's funny. So I'm going to change this in negative input. Press enter. And now it says, probably you need a prime number generator, which is correct. I'm going to accept it. Then this is incorrect, but too bad, I still have to do work myself. So the thing that we're going to use is called assert throws. For people who do not know what it does, it expects two parameters. The first parameter should be the exception that you expect, and the second parameter should be a lambda that calls the code that should throw the exception. So the exception that we expect is called a runtime exception. And look at that. This is exactly the code that I want. I didn't do anything. I'm just going to press tab, but this is exactly what I want to test. So thank you, JetBrains AI. So too bad, my phone is ringing in my pocket. That's really distracting. So I'm going to put it somewhere over here. What I'm going to do, I'm just going to rerun exactly the same commands as before. But now the command points to a file that contains 2 test cases, and before it only contained 1 test cases. Again, we're talking to Llama 3 on my machine. We give it a little bit more time, and look at that. It came up with a solution. It found 2 tests, and both tests succeed. Let's take a look at this implementation, and I expect here, yeah, this is what I expected. See, if you're asked for a negative number, throw an exception. So this is how you add features in this concept. Just add tests to add features. So, what about existing code? The demos that I gave were all to create new pieces of code, but most people in this room, I assume, are programmers. And we all have written at least 100 and maybe more than 1,000 unit tests in our lives. You can also apply this tool to your existing unit tests. And let's see what happens. And actually, that's what I did. I used the tool to improve the tool. So, in the tool is something called a code container. It's a class. And it has a few features. Now, first of all, it holds the code. So you get an answer from the large language model. You extract the code, you put it in this class. And then it has to extract the public class name and transform it in the Java file name, in the file name where we're going to put the code in the file system. And secondly, it also has to extract the package name, so we can use that to create the corresponding file structure in the file system. And if you're a programmer, you know probably the best way to do this is using regular expressions. Now, I have a small confession to make. I'm really bad at writing regular expressions. So I created a poor man's string manipulation solution, and that worked fine in the beginning, but I kept adding tests and tests and tests, and it broke spectacularly. So I had to do something different. So I decided to use the tool to improve the tool. Let me show you this test class. So I told you about file name extraction. Let me see if yeah, the right button. So here are some small implementations. Notice that I put spaces in random spots. Notice that I have classes, I have public classes, and here are the expected enters. So these are the file names that we expect that the method returns. And notice that I added messages. I think adding messages is always good, but in this case it's even helpful, more helpful than normal, because if you provide proper messages, this is the feedback to the large language model. So if a test fails, this message is fed back to the AI and it can easily come up with a better solution. So if you choose your messages right, you help the AI. I do the same for package name extraction. Sorry, wrong button. Again, some small packages, some small classes, again, random spots for spaces. That's what tripped up my poor man's strings manipulation solutions. Notice that I have single level packages, but also multi-level packages and no packages, because package, of course, is an optional thing in Java, so you can also have a solution without a package in there. Again, some answers and some messages. And now we're gonna use the tool to come up with a proper solution for this. So let me, I think this is the right, yeah. So I just copied the path of the file on top. I pasted it in the terminal below. And now my local Llama 3 model tries to find an implementation that solves the test that's currently on top of the screen. And this is not really simple, people. This is something, yeah, I wrote a poor man's solution. So it was, now, probably I would have solved it in the end, but it takes some effort. Now, as you can see, something is happening. It came up with an implementation, but this implementation passed 0 tests. So it's not a very good implementation. It's even worse than my implementation. Let's take a look at the documentation. So there's a generative.log. And as you can see, I'm using OLlama family and the llama 3 model. Now you see here part of the prompt. Then you see the input. This is the test class I've showed you before. And then this is the answer. Now it comes up with, this is normally denotes code. It's using pattern matching, which is very good. And then there's a lot of stuff, yeah, this is too difficult now to understand what's happening, but it doesn't pass our test, therefore it is not good enough. Sorry, what?
Sorry, not switching files.
Yeah, so in the end, it tries for 5 times and it stops. So what's the first thing you do when something doesn't work? Exactly, retry. So that's what we're going to do. But there is also a good reason for that, because we all know about the LLMs sometimes hallucinate, sometimes they're stuck in some corner and they have difficulties getting out of the corner. So retrying is really a valid option over here. But when I practice for this talk, and I practice quite a lot, 50% of the times it's capable of solving this issue. What do we do if it isn't capable of solving the issue? That would be a bad demo, right? Therefore, the first thing I do, first I check the logs if I can find something, maybe, no, it doesn't really matter, it doesn't work anymore. So the first thing I do, I check the logs. Secondly, what you do is you upgrade to a bigger, better, bolder large language model. I'm really happy with the local ones, but the ones in the clouds are at least 100 times better. So if this is not going to work, and this is not going to work, I've done this many times, if you see this, it's not a good sign. So I'm just going to kill it. And if you want to use more than one parameter, you have to use flags. So let's do that. So I'm going to say test file, and then we go, oh, wrong button. Then we go here, and then you say use another family of LLMs. I'm just going to say JetGPT. So what's the difference? Instead of talking to my local LLM, it now goes to the cloud, and it talks to JetGPT, and it defaults to the GPT-4 model, which isn't the most powerful out there, because nowadays we also have GPT-4 Turbo, and I think we also have GPT-4o. So that's the latest one from a few weeks ago. And as you can see, this one is far more powerful, just a one-shot solution. Let's take a look at the solution. Sometimes it's really, let's not spoil the surprise. I'm gonna, where am I? This is the logging, so let's get rid of the logging. And the implementation is, as I expected, a pattern matching solution. One time, actually 2 times already, I gave this talk, and then it came up also with a string manipulation solution, but one that passed all tests. So it is possible to do it with string manipulation. I didn't expect that, but the AI found a solution. Okay, so I used the tool to improve the tool. Just use the tool on your existing test cases and let's see what happens. So I told you in the beginning, there are 2 big issues. The first one was too many manual steps, and the second one is, what about libraries and frameworks? So the tool currently works really well with plain Java code. You didn't see any library in there. But that's not what we do at work, right? At work we use libraries, at work we use frameworks, and I wanted to build a tool that that you can use on your daily job. So, yeah, in its current form, the tool cannot handle libraries and frameworks. And I think that is not a really easy thing to solve, because how would you extract the used libraries and frameworks from a test file? I think that's an impossible problem to solve. There's not enough information to extract all the information about the libraries and frameworks that you're using. So I started thinking, how can I solve this issue? How can I make sure that the tool can also handle libraries and frameworks? And if you think a little bit about it, you pretty quickly come to a point that you think about build systems. Libraries and frameworks are dependencies. Dependencies are managed by your build system. So if you do something with your build system, you'll probably solve this issue. So I decided to create a Maven plugin. Why Maven? I'm more familiar with Maven than I'm with the Gradle, but the principle should also work for Gradle. The idea behind this was the fact that the build system knows about my dependencies. So I expected it to load all dependencies in the JVM, and I can just do all my thing. Now, for people who ever wrote a Maven plugin, they know it. This is not true. But luckily, if you're a Maven plugin, you have easy access to your dependencies. Funny thing, it's just a list of strings containing paths to directories and jar files. That's all there is. And if you have this list of strings, this list of paths, you can just write your own custom class loader. You can load the jar files and the directories yourself. It's not a hard thing to do, but if you've never done it before, you have to fiddle a little bit. And I had one problem after that, after I fixed this. Sometimes the AI comes up with a solution, but not all tests pass. Then you ask for a new solution or a new implementation. And what you want to do after that is reloading a class. You want to unload the old implementation and you want to reload the new implementation. That is not something that class loaders support. So the solution is throw away your entire class loader, build exactly the same one, and it will reload the files. How do you say that? Brute force solution. So, demo time again. How am I doing for time?
Pretty good.
No. How much time did I spend? I have 10 minutes left? Okay, this is gonna be we're gonna hurry people. So, now we're gonna do something with a library. So I created a test called the endpoint test, and the library that we're gonna use is Spring Boot, because that's what most people use, right? So I created something called an endpoint test. There it is. And it's pretty simple. It is a Spring Boot test. Spring Boot tests by default normally have random ports. We use something called a REST template, and we do a get on the root of our local host and our random ports, and we expect it to return hello world. So again, really simple test to start with. I told you it's a Maven plugin, so we have to take a quick look at the POM file. That is where Maven stores all its configuration. And the most important part is over here. There's a new plugin written by me, and it's called the test-driven generation Maven plugin. And its most important part is over here. There's a configuration. You have to provide a path to a JUnit 5 test file. Now, okay, currently it points to the test I've just shown you, the endpoint test. So now again, I go to the terminal. I say Maven test-driven generation, and then generate. And if you do that, the POM file will be read. And as you can see, you will recognize this from the previous demos. The Maven plugin just uses the jar file that I used in the previous demos. And now, by default, it goes to my local Llama 3 model. Now, I told you before, when I practice for talk, I practice a lot for this talk, and normally 20% of the time it can solve this. So this is a pretty hard problem for a local LLM. So very probably we have to upgrade, so I'm gonna prepare that. As you can see, there are some other configuration you can do. You can specify a family, you can specify a model, you can specify a timeout, you can specify a server, you can play with the prompt if you like, but I'm just gonna uncomment this, I was playing proper English. And if you do that, it will go to the cloud, it will use JetGPT and then GPT-4. Now, you see it failed. I'm just gonna give the same command, but now it will use GPT-4 in the cloud. I'm going to take a sip of water because this probably takes 10 seconds. Normally when I practice, this is 50% of the times it solves it in one shot, and sometimes it needs 2 shots. Let's see what happens. You never know. And build success. So let's have a small look at the solution. Oh yeah, that doesn't work, of course. So I expect there to be a solution in here. There it is. I'm gonna make the screen bigger. So we have a Spring Boot application, which is a REST controller. It has a get mapping on root, and it returns hello world. Exactly the answer that we expected. So I've proven that it also works with libraries, but this again was far too simple. Let's step up the game. So I have something else called the endpoint H test. Endpoint H test. So it's the same type of test, but now we're gonna give the endpoint a birth date, and then we expect it to return the H, right? So we give a date, which is a birth date, and then we expect it to return a date. If you're born on the 1st of January of this year, you're 0. If you're born on the 1st of January of 2020, you're 4. 1st of January of 2000, you're 24. Last day of 2000, you're 23. You still have to become 24. So this is a bit of a of an edge case. Notice that we expect an age endpoint and that we expect the birth date to be part of the URL. I go to the POM file. I adjust the name of the file. This is the good one. I go to the prompt, sorry, to the terminal, and I rerun the plugin. So again, notice over here, I'm directly going to go to JetGPT-4 in the cloud. So it's talking to GPT-4 in the cloud. Again, this is also normally it's 1 or 2 shot attempt. So let's hope that it works. I think it's the last demo. Pretty sure it is. I should know, right?
Generated the presentations?
I did not, old-fashioned stuff. I typed it myself by a real human. Build success. So let's see how it implemented it. Close. Now I go here. And it's this one apparently. So we have again the Spring Boot application, which is a REST controller. There's a get mapping on age, and notice that now there is a path variable, which you can also see over here. First thing it has to do, it has to transform the string into a simple date format. So there's some, how do you call that again? There's some, no, I don't know the words, but you have to translate it. It parses the date. Yeah, that's what I wanted to say. Then you have to subtract the date from, interesting, there's a mistake in there. I think it's, what's DOP? Oh, no, this is now, right? This is now, so you extract the now from the date, and then from the difference, you have to extract the years. And it does something really complicated with the age, I don't know why. I think if it's before today, it doesn't do anything, but if it's after today, then it subtracts 1. That was the test case I shown you. If you're born on the last day of the year, you still have to become 24. I don't want to focus too much on the code. Something happened, sorry for that. The Maven plugin works too. That's actually the message I want to think. And I think the endpoint age test, this was not a trivial problem. Again, you have to think about it. How do I solve this? And there were, I would say, like 4 to 5 steps involved. It's not really, really simple. So what does work well? Plain Java code works really well. The first few demos that I showed you use plain Java code. Why does it work well? Because there's a lot of examples on the internet. The large language models are trained on those examples, and therefore it can work really well with plain Java code. Also, it works well with well-known dependencies like Spring Boot, because there's a lot of information about Spring Boot on the internet. What does not work well? If the implementation should have a lot of references to your own code, so let's say your own util classes or your own other code, it doesn't know about your code, right? It only knows about the test case. You only provided the test case, you don't give it context about your project. And also it doesn't work really well with less known dependencies, because yeah, it just doesn't know about those. What if it doesn't work? Now, first thing, you check the logs. Secondly, you upgrade the large language model. I've done that during the presentation. You've seen me doing it. And what if you cannot upgrade to a better LLM? At least you have the unit test. Let me explain this. In the past, I would write unit test, grab a cup of coffee, and then write my implementation. Now I write my unit test, run the tool, grab my coffee, come back, and I hope for a solution. If there is no solution, I didn't lose a lot of time. I only started the tool. So at least you have the unit tests. Pricing. Pretty non-existent when you're using a local large language model. Of course, my laptop runs a little bit hot. The battery dies a little bit sooner, but you probably will not notice it on your current bill. You pay a small price when you play around. To give you an idea, creating this tool, practicing for this talk, cost me less than $10. I still have more than $1 left in my OpenAI account. It will become pretty pricey when you will be using online AIs a lot. But they are getting better, faster, and cheaper every week. So I'm pretty sure in the near future we have a point in which this is a no-brainer to try this first before you write your own implementation. Can I use this myself? Yes, you can. I will share links afterwards to all the projects that I've used and also those slides, so you can play with it yourself if you want to. I do have to warn you, it is proof of concept level. Yeah, I told you I expected to be busy for 5 evenings, turned out to be much more evenings, so I cut some corners. I'm going to skip a few things from here. I'm going to go all over here. My endpoint for this idea is it should be an IDE plugin. So picture this, you're writing your unit test, you right click, you say give me an implementation, you get your cup of coffee, you come back and you're done. That's the end, that's my end goal. Specifically you're saying my end goal because I think there's an other end goal for the idea. I really would like it to be part of Copilot of AI assistants. This actually belongs in a tool that you already use. You shouldn't have a different project or plugin for this. Sorry, what? No, there's no AI system out there that does checking by unit test. That's the unique part. At least as far as I know. Please prove me wrong. Conclusion, last slide. No, yeah, former last, I don't know. TDD and GenAI is a perfect pairing. The principle works. I've shown you several demos in which I've showed off the principle and I think it works really well. The most important thing that I can teach you today is the fact that you have to check the output of your large language model. And that's what we do with tests in this presentation. Thank you. Feedback is more than welcome. I love feedback. I also have a little announcement. In the beginning I told you I work at Sync. We do a... Oh, there's a typo in there. This typo will become clear in a few seconds. So we used to have a speaker academy. We already did 2 instances of it. In this speaker academy, we learn people how to apply for conferences and how to stand on this stage and talk at a conference. If you're interested in that, we're planning to do a speaker academy that's open for external people as well. So for the previous 2, you had to be part of Sync, but for the next one, you don't have to be. I used Strike Through because we had a little legal issue. So we had to change the name to Sprekersopleiding. It's also in Dutch, so Sprekersopleiding is maybe the better term for it. But if you're interested, we will post about it on the socials. I will also ask Maureen to send Maureen an email and ask you to send it to you. So if you're interested, you could also become a speaker if you would want to. That's it. Thank you for listening to me. I hope everybody learned something new.